All right, so today we're in section 2.3, rotations. All right, and we just gave several really good examples of rotations. So what does a rotation mean when it comes to a figure? Does anybody know what kind of figure this is? This kind of goes back to elementary days. It has nothing to do really with our example, okay? It is a trapezoid. You guys remember them trapezoids, right? Okay, very good. Okay, so a rotation or a turn, you can circle it, highlight it, whatever you want to do. Rotation's turn is a transformation in which a figure is rotated about a point called the center of rotation. The number of degrees a figure rotates is the angle of rotation. So while we're talking about degrees, and I'm sure this is somewhere else in your notes as well, but I want you to write it right here. There are 3 degrees of rotations that you're going to learn: 90, 180, and 270, okay? And we're going to talk a minute about clockwise and counterclockwise rotations. But those are the 3 angles of measurement, or an angle of rotation, all right? There's no such thing as a 200-degree rotation, all right? It's literally these 3. It's either 90, 180, or 270. Everybody with me so far? Staying awake? Not falling asleep yet? We good? Okay, it's a little warm. All right, I'm doing what I can on that. Brought my fan today. That's a fan in the back, and then the purifier's up front. Okay? Trying here, guys. All right, I'm trying. All right, so what makes a 90 degrees rotation, or a 180, or a 270? Oh, okay, so we can view it as, okay, like one turn of a figure, okay, counts as a 90-degree turn, okay? So as soon as you turn it once, that's 90 degrees. When you turn it twice, that's 180 degrees. When you turn it 3 times, what do you think? 270, okay? All right, so let's look and see what's happening with the puzzle piece. All right, you need to pinpoint a point on the puzzle piece that's easy to kind of lock into. All right, so I picked the cutout side of the puzzle piece. Okay, so if I were to turn it clockwise, so remember guys, clockwise is to the right. Okay, if I were to turn it clockwise 1 click or 90 degrees, does everybody agree that picture A would be the 90-degree turn? Okay, so 1 click would make the cutout piece face up, all right? So for B, how many turns is it? 180. 2, which would be 180, okay? So B is 180, okay, 180. And then C would be 1 more turn, which would be 270, 270 degrees. Okay, so that would be the 270 degrees clockwise because that was 3 turns. Does that make sense so far? Good. Okay, I know it's kind of hard to wrap your head around it. Okay, but it's just going to take time. So tell whether the blue figure is a rotation of the red figure. So I'm going from red to blue here. Okay, from red to blue. All right, so I need to decide, is it possible to turn the red figure to make it face the same direction as the blue figure?
Yes.
Yes, okay. Now, how many turns would it take to make the red turn to the blue? 2. 2 turns. So how many degrees is that? 90 and then 180. 180 is going to be your 2 turns. Now, we're going to dig deeper into this, okay? Just not right now. Technically, this is a guess, okay? There is a way to prove this, but we're going to do that tomorrow, okay? So for now, I'm just going to settle with this is 180 degrees, okay? Look at number 2 now, all right? So be careful in this because, again, you don't want to guess. You need to be sure. So can you tell for sure if number 2 is a rotation, red to blue? You can't. Why? Because it's a square. So you can't tell, well, yeah, sure, you could have turned it, but it looks the exact same. So this is not a rotation. It is, however, another one of the transformations that you have learned. I want you to write it down. So you've learned 3. Is number 2, from red to blue, an example of, technically there's not just one answer to this, okay? A translation or reflection, or we know that it's not a rotation, all right? Anybody? What do you guys think? It is a translation. Now, look here, guys. You could say that it is a reflection, but when you flip it, it's also going to have to shift up, okay? Because they're not quite matched up. Like the red to the blue goes up, so it's not a true reflection, all right? If you say reflection, you would then have to say it translates 1 unit up, all right? So the better answer, let's just go with the better answer, is a translation.
So on a test, if we put reflection, we might be wrong.
Not if you put translation 1 unit up, but it's going to be 2 to get it there, okay? So it's a translation. Now, how can you describe the translation? You must pick any point on the red triangle, okay? Or not triangle, the red square, okay? Pick any point. Now I need you to pick the corresponding point on the blue square, okay? So would you agree that it would also be the top left point on the blue square? All right? So to describe the translation, you must tell me how many units left or right and how many units up or down it takes to get from the original point to the new point. All right? So let's count. Okay? From the red to the blue, we go left how many? 1, 2, 3, 4. Then we go up 1. So you would say translation, 4 units left. Okay, you can just say 4 left. I'll be thrilled with that. Okay, and then 1 unit up. All right, are you guys writing this down? You guys writing this down? Okay. All right, any questions on that? Do you see how we did that? So on your quiz and your test, all the translations that you've learned, all 3 of these are open game. You're going to have to be able to tell if it's a rotation, what kind of rotation, or a translation or a reflection. All right? And then describe it. Okay? All right. So, let's talk about codes for a second. You will be given these codes on your test. All right? And there's a reason why, okay? In Algebra 1, your transformation codes change a little bit. Okay? And because they change, it doesn't necessarily build the exact same way. All right? So that's why I give them to you on your quiz and your test. Okay? All right. So has anybody ever, well, first of all, has anybody ever used the combination on your locker? Yeah. You better all raise your hand, right? Has anybody ever opened a safe with a combination? Have you guys opened a safe before? All right. So it's essentially the same thing, right? There's only one combination that's going to open it, right? But as soon as you open it, okay, as soon as you know the combination and you can open it, then you can see exactly what's inside, right? So the rotation codes are essentially the same thing in that as soon as you understand how your ordered pairs are changing with the rotations, you can do any of them, all right? But you have to understand the codes. All right, so first thing, all right, I want you to notice something similar about the first ordered pair in the set. Noah, would you mind hitting this front row of lights right here just so we can see a little bit more of a contrast? Okay, yep, perfect. Okay, so what do you guys notice about all 3 of these ordered pairs? Are they any different? No. They're all the exact same. So what does that mean? That means that this original or this ordered pair means the original. Okay? That's the original ordered pair. No matter what the sign is, that's just the starting ordered pair. Okay? The second ordered pair shows me how I'm going to change the first ordered pair. Okay? So when I see it flip, to y and then x, I know that I need to flip the order of the ordered pair. Watch this, guys. I need to flip the order of the ordered pair to do this rotation for that point. Okay? We're going to talk about why two different rotations can be the same ordered pair. Now let's look at this negative. Okay? So you have to understand what the negative means. If you don't hear anything else, please hear this. This is so important, guys. Okay? The negative does not mean the value is negative. The negative means that whatever value the y value was in the original, it will now be the opposite. Okay? So the negative tells me you're going to make it the opposite value. Okay, Kate?
What exactly are we doing? Is it the whole thing? We have to write.
You're gonna have this on the screen. You're gonna have the codes on the screen. Okay?
Like we'll have to write it?
No, you're going to have to use the codes to rotate ordered pairs and figures on the graph, okay? All right, so let's talk about the fact that one code is two different directions. It is counterclockwise 90 or clockwise 270. So how can the same code be two different directions? I'll show you, okay? So let's say we have an XY axis right here, okay? All right. Now, you guys remember we said that one turn is 90 degrees, right? So how many degrees is two turns? 180. How many degrees is three turns? 270, okay? So here we start with, let's say, point A. Hold on. My pencil's not writing, okay? So point A is here. So would you agree that a 90 degree, all right, now don't count the spaces, we're just doing directions here. Okay, a 90 degree rotation clockwise would give me A prime right here. Would you agree that this is one turn, 90 degrees clockwise? Okay, but what if I said 270 counterclockwise? Now I'm going to go the opposite direction from the same original point, okay? I'm going to go 1, 2, 3 to the same exact final destination for that point. Do you see that? Okay, so guys, that's why 90 degrees clockwise and 270 counterclockwise is the same ordered pair. Do you see that? Do I need to explain that again? Okay, all right. Look here. 90 degrees clockwise is one turn to get me down to that point. Do you guys see that? One turn to get me here. 270 counterclockwise, the opposite way, is 1, 2, 3 turns, but I end up in the same place. Okay, so that's why it's the same ordered pair. I'm going to go back to your codes. Okay, that's why counterclockwise 90, one turn to the left, is the same thing as 3 turns to the right. Okay? Sort of makes sense? Okay, all right. So there's your codes. We're just going to leave it there. The more I talk about it, you're not going to get it anymore. We just need to go over it again tomorrow, okay? All right, so let's practice rotating these figures. All right, so we need our code. You're going to need to look back at your codes. 180 degrees about the origin. I want you to write the code next to this problem. So you have your original ordered pair, and it tells me how to rotate it. Okay, x, y, and then negative x, negative y. And I need to remind you guys, okay, the second ordered pair tells me how this point rotates. Okay, so am I flipping the order? No, I am not, because x and y are still in the same order. What I am doing, because the negatives are there, is I am reversing the sign. Don't fall asleep on me. Okay, I'm reversing the sign. All right, so let's look at my first one. All right, my original x value is what? -4. So now if I want to rotate this point 180 degrees, Now it is positive 4. And I must do the same thing with y. All I'm doing is doing the opposite sign. That's a 180-degree turn. Okay? All right, so that's what those negatives mean in the code. All right, I need a set of notes. Nope, that's not it. Okay, so what do you think the next point is going to be?
4.
Okay, very good. So now it was negative 4. So now it's going to be positive 4. It was positive 2. So now it's going to be negative 2. I do the opposite. All right, you try L and M now. Very good. 1, 0. I mean, guys, we can't do the opposite of 0, right? So it's just going to be 0. All right, what about M? Sequest, what'd you get for M? 2 and 3. Very good. Okay, so now we're going to go 90 degrees counterclockwise about the origin. So I want you to look back to your codes. Okay, do you see 90 degrees counterclockwise? It's your first code. Okay, which clockwise rotation is the same thing? 270. Okay, because now we're going either 1 click to the left or 3 to the right, but it's the same ending point. Okay, so I want you to write your code next to this problem. So we have X, Y. And then how do they change, guys? No, negative Y and X. Okay, so now this means that my order of my ordered pair is flipping. Now my Y value will come first, but look here, guys, look up here at the screen for a minute. Okay, my Y value, when I write it first, I must make it the opposite sign. Okay, that's what the negative means here. It means to flip the order and then make that the negative sign. Okay, or I'm sorry, the opposite sign. So it was 2, but now it's going to be what? Negative 2. And then you keep your X value the same. You don't do the opposite of X. Okay? No, you don't do the opposite because it's just X on the switch. If you were doing the opposite of X, it would be negative in your code. Okay? All right, so negative 2, negative 3 is point P. Does anybody want to give point Q a shot? What do you think, Rome? Okay, so he said negative 1 and positive 6. Do you guys agree with him?
No.
Okay, he is correct. He switched the order, and my Y value was positive 1, and now it is negative 1. All right, I want everybody to get the ordered pair for R down if you haven't already. Okay, write down your ordered pair for R. Okay, Gavin, what'd you get for R?
I got 5 and
Okay, so 5 and negative 1. Do you guys agree with Gavin?
Yeah.
Okay. All right, very good. Good job, guys. All right, so how do you guys feel so far about rotations? Okay, visually, okay, each turn is 90 degrees. Now we're starting to rotate points, all right? And then we're also analyzing graphs to try to figure out what kind of rotation happens. So there's a lot going on here, all right? This, out of many, many lessons that you have in this curriculum, this is definitely a 2-day lesson. Like, there's no doubt about it, okay? Because it's a lot of new information, right? Have you guys ever seen anything like this? No, you haven't. I know what you learned last year, okay? You haven't. So we're going to break here, okay? We need to talk about your projects, and I need to look at your homework work, okay? So tomorrow we're going to do a classwork assignment, and there's one other thing I need to work on with you. Classwork assignment, projects, and just finish this lesson, okay? So that means that the homework that was scheduled for tomorrow night will not be your homework tomorrow night, and I've already changed it on Big Ideas, okay? So I know you're really disappointed to hear that, but we're not going to learn the new lesson tomorrow, okay? I need another day to do rotations and to review reflections because I wasn't here yesterday. Okay? All right, so that's everything you need to know for today.